let's say I've got a set of numbers, 2, say I've got 3 threes, I've got a couple of 4s, and I've got a 10 there. And what we want to do is find the middle of these numbers. We want to represent these numbers with the center of the numbers, or the middle of the numbers, just so we have a sense of where these numbers are, where they roughly are. And this central tendency that we're going to try to get out of these numbers, we're going to call the average. The average of this set of numbers. And you've, I'm sure, heard the word average before, but we're going to get a little bit more detailed on the different types of averages in this video. The one you're probably most familiar with, although you might have not seen it referred to in this way, is the arithmetic mean. Arithmetic mean. Which literally says, look, the arithmetic mean of this set of numbers is literally the sum of all of these numbers divided by the number of numbers there are. So the arithmetic mean for this set right here is going to be 2 plus 3 plus 3 plus 3 plus 4 plus 4 plus 10. All of that over, how many numbers do I have? 1, 2, 3, 4, 5, 6, 7. All of that over 7. And what is this equal to? This is 2 plus 9, which is 11, plus 8, which is 19, plus 10, which is 29. So this is going to be equal to 29 over 7, or you could say it's equal to 4 and 1/7. If I got my calculator out, we could figure out the decimal of this. But this is a representation of the central tendency, or the middle of these numbers. And it kind of makes sense. 4 and 1/7, it's a little bit higher than 4. We're kind of close to the middle of our number range right there. And you might say, well, it's a little skewed to the right. And what caused that? And well, Jesus, 10 is a little bit larger than all of the other numbers. It's kind of an outlier. Maybe that skewed this average up, the arithmetic mean. So there are other types of averages, although this is the one that if people just say, hey, let's take the average of these numbers, and they don't really tell you more, they're probably talking about the arithmetic mean. The other forms of average, though, are the median, and this literally is the middle number. The middle number. And if there are two middle numbers, you actually take the arithmetic mean of those two middle numbers. You actually find the number halfway in between those two middle numbers. So the median of this set right here, let me just rewrite them. So I have a 2, 3, 3, 3, 4, 4, 10. So let's see, we have 7 numbers right here. The middle number, if I go 1, 2, 3 to the right, we're there. If we go 1, 2, 3 to the left, we're there. The middle number is that 3 right there. I just listed them in order, and I said, well, like 3 is, you could think of it as the 4th number from the right, and it's also the 4th number from the left. 3 is the middle number, and in this case, it is the median. So in this case, 3, if you use the median, is our average. And that also makes sense. I mean, it's literally the middle number. And if you look at this set of numbers, it kind of does represent the central tendency of this set. Now, just to be clear, it was very clear what the middle number was because I had an odd number of numbers. It was, I have 3 on each side of the 3. So it was very easy to figure out the median, the middle number. But if I had a situation, let's say I have the situation where I have 2, 3, 4, and 5. Let's say that's my set of numbers. Well, here there is no one middle number. The 3 is closer to the left than it is to the right. The 4 is closer to the right than it is to the left. There's actually 2 middle numbers here. The 2 middle numbers here are the 3 and the 4. And here, when you have 2 middle numbers, which occurs when you have an even number in your data set, there the median is the halfway in between these two numbers. So in this situation, the median is going to be 3 plus 4 over 2, which is equal to 3.5. And if you look at this data set, that's not what our original problem was. But if you look at this data set right there, you're actually going to find that the arithmetic mean and the median here is the exact same thing. Now let's calculate it. What's the arithmetic mean over here? It's going to be 2 plus 3 plus 4 plus 5, which is what? 5 plus 9, which is equal to 14, which is equal to 14 over 4. Over 4. And what's this equal to? 14 over 4 is 3 and 2/4, or 3 1/2. The exact same thing. So for this data set, they were the same thing. For this data set, our median is a little bit lower. Our median is a little bit lower. It's 3, while our arithmetic mean is 4 1/7. And I really want you to think about why that is. And it has a lot to do with this 10 that sits out there. All of these other numbers are pretty close to whichever average you want to pick, whether it's the arithmetic mean or it's the median. But this 10 is kind of an outlier. It's kind of an outlier, or it skews the data set. Maybe it's so much larger than the other numbers that it makes the arithmetic mean seem larger than maybe is representative of this data set. And that's something important to think about. When you're finding the average for something, most people will immediately go to the arithmetic mean. But in a lot of cases, median will make a lot more sense if you have these really large or really small numbers that could skew the data set. I mean, you could imagine if this wasn't a 10, or let's imagine adding another number here. If I added the number 1 million, if I added 1 million to this data set, if that was the 8th number, the arithmetic mean is going to be this huge number. It's going to be much larger than what is representative of most of the numbers in this data set. But the median is still going to work. The median is still going to be about 3 1/2, right? If you had a million here, it'd be 1, 2, 3, 4. 1, 2, 3, 4. The middle two numbers would be that. It would be 3 1/2. So the median is less sensitive to one or two numbers at the extremes that otherwise would skew the mean. Now, the last form of average I want to talk about is the mode. The mode has nothing to do with ice cream. The mode is literally the most frequent number. Most frequent number. And in this data set, it's pretty clear what the most frequent number is. I only have 1 2, I have 3 3s, I have 2 4s, I have 1 10, and if you want to include the million, I only have 1 million there. So here, the number that occurs most frequently is the 3. So once again, the mode seems like a pretty good measure of central tendency, or a pretty good average for this data set. Now, the mode, it's a little tricky to deal with, and you won't see it used that often because it becomes a little ambiguous when, I mean, look at this data set: 2, 3, 4, and 5. What is the mode there? All of these numbers are equally frequent. So if you have a situation like this, then you might just, the mode really loses its meaning, and it might force you anyway to take the median or the mean in some form. But if you really do have numbers that kind of, one shows up a lot more than the other, then the mode starts to make sense. So hopefully this has given you a pretty good overview of how to represent the central tendency, of a data set. Very fancy word, but it's just saying, look, we're trying to represent with one number all of this data. And you might say, hey, why do we even worry about that? I only have 7 numbers here, or 8 numbers here. But you can imagine if you had 7 million numbers or 7 billion numbers, and you don't want to show someone all of that data. You just want to give someone a sense of what that numbers are on average. On average. And as we said, the arithmetic mean is what I see being used the most. But in situations where you might have numbers that would skew the arithmetic mean because they're so large or they're so small, the median might make a lot of sense.